Hi, the question today is about three-dimensional geometry, angle between a plane and another plane. The question reads, the figure below shows a triangular prism ABCDEF. If given that AB is 12 centimeters, AE is 20 centimeters, AC, ED, BC, FD are all 10 centimeters, calculate the angle between plane ADB and the base. So this is the diagram. Before we calculate the angle between the two planes, let's identify the planes. We have the base and plane ADB. Now the base is the bottom part, ABFE, just as shown. And then plane ADB is right here, ADB, again, just as shown. Now the angle between two planes is the angle between two lines which lie on the two planes, such that the two lines meet the edge of the two planes at 90 degrees. For example, this line here lying on ADB meets the edge AB at 90 degrees. Similarly, the other line lying on ABFE, that is the base, also meet the same edge at 90 degrees. Now, another thing worth noting is that these two lines also bisect the edge AB. Alright, so the two lines meet at an angle. Now that angle, say theta, is the angle between the two planes. So if we complete this end to form a triangle, of course it's a right angled triangle at that point, so that if we name the base XY, then triangle XYD is a right angled triangle. Considering the right angled triangle XYD, the side XY is already known. It is 20 centimeters because XY is parallel and equal to BF, which is already 20 centimeters. Remember, we'll be interested in this triangle because it will help us get the size of angle theta if we know the measurement of at least two sides. So already we know XY and we can determine DY. So let's consider this triangle here, a right angled triangle, DYF, whose dimensions are given as follows. So let's extract it. So we have DF is its hypotenuse and it's 10 centimeters. YF can be shown to be 6 centimeters. Remember, YF is a half of EF. EF is equal and parallel to AB. And if X is at the midpoint and XB is 6, then that means YF is also 6 centimeters. So that's why we have it here as 6 centimeters. Now we are left with DY to determine. And because this is a right angle triangle, we can use Pythagoras theorem to determine the value of dy. So we'll have the square root of hypotenuse squared minus base squared, and hypotenuse is 10, base is 6. So 10 squared minus 6 squared. So this is the square root of 100 minus 36, that is root 64, and therefore dy is 8 centimeters. Now, having known the value of dy, we can therefore extract triangle XYD. Remember, it is XYD that will help us determine the size of angle theta. Now, if we know XY and dy, just as shown here, if dy we've already determined as 8 centimeters and XY we also saw was 20 centimeters, then with this we can go ahead and determine the value of theta. Now, since this is a right angle triangle, dy and xy are related to theta by tangent. So we say tangent of theta is equal to opposite over adjacent. Opposite is 8 centimeters over adjacent 20 centimeters. This simplifies to 2 over 5. Now, to get theta, we find the tangent inverse of 2 over 5, and that is 21.8. So 21.8 is the angle between the two planes, that is plane ADB and the base as desired. With that, we mark the end of the solution to this problem. Thank you for watching. Hope to see you in the next video. Bye.